Hello everyone, welcome you all for the third day of course on mathematical analysis, abstract algebra, linear algebra organized by the Department of Mathematics, Farouk College. Mathematics is not about equations, numbers, or computations or algorithms, but it's about understanding. Today, with Today, I am very excited to introduce our resource person of today's session, Mr. Mohammad Nishad Maniparambat, a very young and excited personality. He is the assistant professor of our Department of Mathematics from 2013 onwards. He is an academic advisor of many educational institutions and an eminent resource person of massive open online courses conducted by the Educational Multimedia Research Center of Calicut University. He has delivered he has delivered introductory talks to UG students of various colleges. Also, he is an active member of the Internal Quality Assurance Group of Farouk College and a member of Board of Studies of Farouk College. With great pleasure, I invite Mr. Mohammad Nishad Maniparambat to start the presentation. Over to you, sir.
Okay, thank you very much, ma'am. All is new for headphones sound system. Okay, I welcome you all, and we have two more of presentation here. One is we are presenting to Google Meet, and one is we are presenting to YouTube Live. Any of the presentation you can follow, no problem. While presenting, because I'm using the note also, maybe sometimes I forgot to change the slide on presentation. That time we will focus on board also. Okay, thank you. And one more thing is that while starting this course, it was on the abstract algebra, linear algebra, and domain analysis. Firstly, we thought that we have to restrict this is for our students, college. But we understood is our understanding from the news is that many of the students are coming into first year, final year students. They are with their very good understanding level, knowledge level, even though sometimes they are unable to prepare the final classes. Because the paper is completely contain a theoretical way of mathematics, the students have to learn and understand how they can deal the theoretical mathematics. In and it is a very great lesson to all us is that we are sharing this content to many of the students of the all over our country, from Kashmir to Kanyakumari. Many state students are, many university students are attending our program, and I welcome all to the session. And one more thing is your future for our society, for the development of our nation. So that is why we start this kind of take you to take you to new course of mathematics. That is the final class of mathematics. Okay, and I welcome you all for this session. In this session, just I am introducing what you learned from the former classes and what the things we need to start abstract. I'm not discussing more heavier things. I'm discussing only very basic facts on abstract algebra. And my dear students, I'm welcoming to this session. And for this session, I just start with this binary operation. And we all are familiar with the binary operation from your basic standard. So, from all these classes, you all know a very base binary operation is that addition, subtraction, multiplication, and division You all are very much familiar about these binary operations. From this, by addition, from the very basic classes, we start this binary operation and subtraction as well as multiplication and division, all things basic classes onwards. And that is also a binary operation. As because it is a binary operation, we can say that instead of addition, we take instead of addition, we sum these two numbers, that is a plus b. And for subtraction, we have a minus b. For multiplication, we have ab. And for division, we have a by b is there. But the denominator should not be equal to zero. If the denominator is equal to zero, what will happen is that it is, and we can say that these are the binary operations. Very basically, we know about it from our very basic standard units. Now, we move to our next part. And okay, so I'm skipping this sentence, all those things. While discussing on this binary operation, while we are entering theory, we are discussing on that here we are using an arbitrary set. Here we are using an arbitrary set x. The arbitrary set x is as like a set, it contains maybe finite number of elements or infinite number of elements. And in general, we are defining a binary operation. It is the association of any pair of elements AB from X to another element. From AB to any pair of elements AB from X to another element of X. That is why we are able to do many parts of it. Before going to that, we can define what is actually a binary operation. A binary operation is nothing but we can take it as a star, a simple a star, a star. Just 1 minute. I'm removing this all things from here. Okay, a binary operation and star from A cross A to A, where A cross A is a set, it's a cross product, it's containing pair of elements. That is why from every element of A cross A is mapped to another element of A. Then we can say that star is a binary operation. That means star of AB, will get a new element, A star B. That A star B should be an element of A. A star B should be an element of A. And we already discussed addition and division. See, while discussing, as an example, I would like to come to with an example. See, is addition, subtraction, multiplication are binary? The set is very much important. Is addition, subtraction, multiplication, division are binary operation on R? Definitely, we can say that it's a binary operation. We are moving on. What about the division? Is division binary operation? So, is it not a binary operation on R? And we discussed that A by B, where the denominator B not equal to 0. See, I'm taking into one more thing is that uh, division is further, even if division is not a binary operation, can we say that it is binary operation on R star, where R star is the set of all non-zero real numbers. See, our discussion is going. Our first discussion is addition, multiplication, subtraction are the binary operation. See, addition, we have addition here. addition plus from R cross R is given by, we can say that it is available plus of AB to another element A plus B. And plus of AB to another element A plus B, and similarly our operation minus. Minus from R cross R is given by minus of AB. That is equal to A minus B. Sum of two real numbers is again a real number. Therefore, addition is a binary operation. Similarly, minus from R cross R to R. While subtracting a real number from another real number, definitely we can say that the answer should be a real number. That is why we can say that this is also a binary operation. So both these cases we can say that this is plus is a binary operation. This is a binary operation. Plus is a this is a binary operation. Plus is a binary operation. Similarly, minus is also a binary operation. And our discussion, we will move to what will happen in case of multiplication. While multiplying two real numbers, we can say that multiplication of two real numbers as multiplication of two real numbers as multiplication of two real numbers multiplication two real numbers AB equal to AB. While multiplying two real numbers, definitely we can say that this is belongs to set of real numbers. This is belongs to set of real numbers. Multiplication of two real numbers AB equal to the product AB, product of two real numbers is again a real number. That is why we can say that multiplication is also a binary operation. Now, we will move to another part, that is we know the discussion division. That is, in case of division, what will happen? The what about division? Division is a binary operation. That is our thought. See, in case of division, we can say that in case of division, division of AB equal to A by B. It's not a function because if there is a chance for B taking the value 0, that is why the denominator will be 0. If B equal to 0, A by B is not defined. A by B is not defined. However, see what will happen if A by B instead of B, if B is not receiving the value 0, or if both A and B are not receiving the value 0, then we can say that it may be of R. Simply we can say that we will take another set, that is what is the R star. That is what is the R star. In R star, we can say that in R star, uh, in R star, the elements A by B is available for P for all A and B are non-zero real numbers. In just 1 minute, just sorry for the people in Google Meet. Okay. We are streaming this to YouTube and as well as Google Meet also. That is why this maybe some delay will be there. Sorry. Okay, welcome again to our session. Come to here. So A by b is a function and hence it is a binary operation on abstract. So again, our discussion is subtraction and binary operation on n. Subtraction and division are binary operation on n. The set n, set of natural numbers, set of positive integers. We can think about the subtraction. Subtraction minus from n cross n to n. It is given by a by minus of ab is converted to a minus b. Where a minus b, think about a minus b. If both values are from the natural numbers, both a and b are from the natural number. If b is highest value than a, the provide as a negative value, a negative integer. That negative integer is does not belongs to n. Negative integer that is does not belongs to n. Negative integer is does not belongs to n. Okay. A negative integer that does not belong to n. Okay, now come to here. The negative integer does not belong to n. There is a little technical mistake is here. Well, clear it is as earliest. Okay, the page transparency is not working. Okay, listen. Okay, listen. So a minus b, if b is highest value, we are taking the page 3 and 5. This is from n cross n. And therefore minus acting on this like 3 and we have 3 and 5 is here. 3 minus 5 is equal to minus 2. As I said to you earlier, minus 2 is not an element of n. Similarly, we can take as division. Division from n cross n to n is given by all pair AB is operating like A by B. Operating like by B, and it is not a binary operation. Because while taking the phase 3 and 5, 3 divided by 5 is equal to 3 by 5. 3 by 4 definitely a rational number. It does not belong to it. It's not an element of n. That is why we can say that division, while dividing two members, 3 and 5 from n, the result value 3 by 5 does not belong to it. That is why division is also. That is why we can say that both division and multiplication and division are not the members of both multiplication and division are both multiplication and division both multiplication and division are not sorry and just disturbing this. So the system has little hangs. Okay. Both. Okay, no problem. Come back to you. Both multiplication and division. Both subtraction and division are not binary operations. Okay. Okay. And similarly, we can move to another slide. We are moving to another example. The example says to us to is that show that star. We define star from R cross R to R is given by AB. A star B equal to A plus 4B square is a binary operation on R. Think about star carries each pair AB to A plus 4B square. Each pair, AB to A plus 4B square. It's a binary operation. See, uh, B is a real number, and we are discussing on the binary operation on set of real numbers. Since B is a real number, B square is also a real number. And similarly, 4B is also a real number. Say A is a real number, 4B square is a real number. This is like sum of two real numbers. As we know from our basic classes, sum of two real numbers is again a real number. Sum of two real numbers is again a real number. That is why we can say that star carries each pair AB to a unique element A plus 4B square. The A plus 4B square is an element. A plus 4B square is an element. A plus 4B square is an element on R. So we're happy. We are moving to the next part and we will move to another example. In the next example, we are considering a set P, a set P with a set of all sets of the given set X. And uh, we define two operations, that is union and as well as intersection. Union, we define union from P cross P. It is given by it is given by AB operation is there. AB converted to say all AB operating like A union B. We all are very familiar on the intersection. The intersection we define intersection is also from P cross P to P. It is given by intersection of AB as the A intersection B. See, intersection of A intersection B. See, it is very clear to us is that while A and B are two subsets of X, B is the collection of all subsets of X. While you are making union on two subsets of X, we will get a new set that should be also a subset of X. That is why we can say that A union B is again A union B is again an element of B. That is why we can say that union is a binary operation. That's why we can say that union is a binary operation. We can say that union is a binary operation. So we can move to intersection. As we said union, we can say about the intersection is also intersection across P to P. Both A and B are two elements of P. Where P containing all the possible subsets of X. That is why we can say that the intersection of two sets is again a subset of X, so that we can say that P which is contained in P. That is why intersection is also a binary operation of X. Due to some technical problems, I couldn't write on here. That's why for other things I will write on the blackboard. And while There is a little delay, maybe. Okay, we can come to another part. Okay, intersection is also a binary. Now we can move to another example. We are defining a new operation that is each and join. And firstly, we start with a join. Join from R cross R is defined as join of AB as maximum of A and B, where A and B are the real numbers. Simply, while thinking about it, we can say that maximum of two real numbers is again a real number. That is why maximum of AB should be a real number. So that we can say that while operating this one, we can say that maximum of AB is a real number. That's why join should be a binary operation. We can think about meet. Say meet is defined as we define meet is also from R cross R to R is given by meet of AB is equal to minimum of AB. So definitely meet of AB, minimum of AB, since A and B are real numbers, as we said earlier, in case of the join, since A and B are real numbers, simply their minimum is also a real number, so that we can say that meet is also a binary operation. That we are telling on the next line, carries each pair of AB to R cross R to a unique element, namely the maximum of A and B lying on R. That is why join is a binary operation. And similarly, we can say that in case of meet, then same thing, instead of maximum, in case of meet, we are discussing minimum. Minimum of let us say meet, so that we can say that that's also a binary. Now, my dear friends, we are moving to another remark. From our definition, join is the maximum of two real numbers, and meet is a minimum of two real numbers. Say, join of 4 and 7 is equal to the maximum of 4 and 7, that's why 7. Join of 4 and minus 7 is maximum of 4 and minus 7, that is equal to 4. Meet of 4 and 7 is the minimum of 4 and 7, that is why it's equal to 4. And meet of 4 and minus 4 and minus 7 equal to minus 7. So that we can say that the operation the operation is possible. No, okay. That is in case of small number of elements in set for representing this operation, we are able to form the operation. Say, for example, we have taken a set as a equal to 1, 2, 3. And then the operation join on A is defined by the above example that can be expressed as the following operation. As we discussed earlier, join of 1 and 3 equal to 3, join of 2 and 3 is equal to 3, join of 1 and 2 is equal to 2, and we can so we are able to we are able to we are able to draw a table. We are able to draw a table. Okay, there is a technical mistake happens again. I'm sorry. We can go through this way. 1, 2, 3 is there and 1, 2, 3 is here. The maximum of 1 and 1 is 1, maximum of 1 and 2 is 2, maximum of 1 and 3 is 3. And maximum of 2 and 1 is 2, maximum of 2 and 3 is 2, maximum of 2 and 3 is 3. Similarly, maximum of 3 and 1 is equal to 3, maximum of 3 and 2 is equal to 3, maximum of 3 and 3 is equal to 3. So that we have, it is okay. It is what is called the operation table of meet. So sorry, join. For all these cases, for all finite cases, we are able to draw the operation table. Based on this operation table, this is all things for discussing group theory. In case of groups, many properties of groups can be analyzed by using this operation table. In the case of the finite group, whether it is abelian, cyclic, all things we can easily identify by using this operation table. See, generally, instead of these three elements, if you are taking n number of elements, so we are taking the set A as we are taking the element set A as is equal to A1, A2, etc. An. Then the operation table containing n rows and as well as n columns. Among that operation table or operation matrix, we can identify there is an ijth entry. Ijth entry is the entry in the ith row and jth column. That is the ai star aj, where star is the binary operation we defined on A. So by using this operation table, we can understand many things from here. And conversely, given any operation table having n rows and n columns, with each entry being an element of A1, A2, etc. We can define a binary operation star given by a star, a I star aj, the entry in the ith row and jth column of the operation table. So this is very simple concept, and all these things can be discussed from operation table. The very simple operation table that we discussed earlier. This is what happened in case of such things. Think about we are expanding number of elements into n instead of three. That is why we will have n columns as well as n rows. There is ijth entry is there, ai star aj will be there. Okay. Uh, Next part is another important one. Oh, listen. One may not match three and four. 3 and 4 we have. In these two simple numbers, 3 and 4, the 3 and 4 we can add 3 plus 4 is equal to 7. Similarly, 4 plus 3 is equal to 7. And similarly, what will happen if they multiply? 3 into 4 is equal to 12, and similarly, 4 into. But what will happen in case of subtraction? Well, subtraction 3 and 4, what will happen? Well, if you are subtracting 3 and 4, the thing is that 3 minus 4 is equal to, sorry, 3 minus 4, 3 minus is equal to minus 1, but 4 minus 3 is equal to 1. They are not equal. So, similarly, while dividing 3 by 4, which is not equal to 4 by 3, both are different. So, that is why we can say that both 3 plus 4 is equal to 4 plus 3, as well as 3 into 4 is equal to 4 into 3. But 3 minus 4 not 3 minus 4 not equal to 4 minus 3, and similarly the 3 by 4 not equal to 4 by 3. So there is some operating, there is some specialty here. They are commuting, they are commutative. This addition and multiplication are meaningful in this sense But in the case of subtraction and division of 3 and 4 are for this sense only. They have another meaning is there for commutativity. So we are defining by using the definition. These things what we discussed leads to a very fair and interesting definition. This have very vital role in the case of group theory. The definition is a binary operation star on a set X is called commutative. Is called commutative. Is called commutative if A star B equal to A star B equal to B star. For every A comma B belongs to X. The parent set is X. That is why we are taking elements from X. So that kind of operation is called a commutative operation. In case of satisfying commutativity, such group equivalence, I believe that we will discuss later on group theory. Okay. Now, what I discussed here, that only I am just mentioned here as an example. We have show that. Don't mind about show that. Yeah. Plus from R cross R to R and products multiplication from R cross R to R are both the binary operation on R are commutative binary operation. Already we discussed. But minus is not commutative. Similarly, the division. We define division is a binary operation on R star. That is why division is not commutative operation. The examples that we discussed just before, that only I'm mentioning here, A plus B equal to B plus A into B equal to B into A for every AB belongs to R. But plus and products are commutative. However, minus is not commutative that we discussed earlier. 3 minus 4 not equal to 4 minus 3. And similarly, 3 by 4 not equal to 4 by 3. So both the subtraction and division are not commutative operations on R or R star, but addition and multiplication are the commutative operations. This is very clear and simple, and the commutative law have very vital role in group theory as well as in ring theory. See, we will move to the next part. This I'm reducing the size of this slide for convenience. Uh, you can say that. So you don't mind about what I wrote here. Show that come to operation star. Star is what I wrote here. Show that come to operation star. Star is a binary operation on R. For the convenience, I just left to say R cross R to R. Just I will say is a binary operation on R. We define A star B as A plus 2B. The first and is not commutative. See, think about we are just taking two elements, 3 and 4. The first, instead of A, we have 3 is here. Instead of 4, we have, instead of B, we have 4 is here. So think, think that uh, 2B is here. That is why 2 into 4, 8 is here. And similarly, we have uh, 3 plus 2b, that is equal to 3 plus 8 is equal to 11. And similarly, 4 star 3. Instead of b here, we have 3 is here. That is why we can say that 2 into 3, that is equal to 6. So that 4 plus 6 is equal to 10. From both these values, 11 and 10, we are clear that it is not commutative. See, okay, are not commutative. We will move to another example. Okay, it's already written. Okay. If we want to associate three elements of a set, generally we have taken through binary operation on X. We encounter a natural problem A star B star C. How we will interpret the A star B star C may be interpreted as A star B star C and A star B star C. The both have different meaning in some cases. In some cases, they are equal. Our interest is in which cases these two expressions are equal. So need not be same always, but in some extent, that is our interest. Think about this one. We have one example here. That is in bracket. I have put it as 8 minus 5 and minus 2. Clearly, 8 minus 5 minus 2. We have 8 minus 5 minus 2 is here. And we can say that okay, no problem. 8 minus 5 minus 2 we have 8 minus 5 minus 2 is equal to 8 minus 5 is equal to 3 and 3 minus 2. We give priority for the bracket. That is what 8 minus 5 is equal to 3 and 3 minus 2 is equal to 1. Similarly, here we have 5 minus 2 here. 5 minus 2 is equal to 5 minus 2 is equal to 3 and 8 minus 3, sorry, 8 minus 3 is equal to 5. That means 1. Here in left side we have 1, right side we have 5. That is why we can say that they are not equal so that in some cases these both the expressions are not equal. But there is a chance to be they are equal. Association of three numbers to binary operation in case of are meaningless. You may think about what is the meaningless, the associativity of subtraction. Well, I'm just taking addition. What will happen in this addition? We are taking three numbers 8 plus 5 plus 2. See, 8 plus 5 plus 2, say that 8 plus 5 is equal to 13, 13 plus 2 is equal to 15. I'm taking the bracket 8 plus 5 in brackets. So 13 plus 2 is again 15. And similarly, I'm taking the bracket 5 plus 2 is equal to 7, 7 plus 8 is 15. So that we are all the answers are equal. That means they are associated. So that we can say that these three numbers are associativity is meaningful. So that we can say that association of three or even more than three numbers through addition is meaningful without using brackets. Okay, see, we will move to when this we will move to that we already discussed here the binary operation star. A binary operation star from A cross A to A is said to be associative binary operation. Is said to be associative binary operation. When we can say that associative binary operation, if both these two expressions are equal, that means A star B star to A star B star C. For every A, B, C belongs to the parent set A. See, we will move to another example that the things we done here that only I am showing as example show that addition, multiplication are associated with binary operation. We already we don't want to show. The show is a very big question in case of us. So don't mind it. This time representing show that addition and multiplication are associated with binary operation. But subtraction is not associated. That also we did here. Division is not associated. Division is a binary operation on R star, but it is not associated. Think about we shown that sum of two real numbers is a real number, and a plus b plus a plus b plus c equal to a plus b plus c. And similarly, product of three real numbers a into b into c is equal to a into a into a into b into c. These are in all cases they're associated. But our focus is on subtraction. These two sides are not equal. 8 minus 5, we are giving priority for brackets. 8 minus 5 is equal to 3. 3 minus 3 equal to 0. That is why left side is equal to 0. Our board is not working. That is why I could not show here. You may understand. That is very simple, very basic problem. And 5 minus 3, we are giving priority for bracket. 5 minus 3 is equal to 2. And similarly, 8 minus 2. 8 minus 2 is equal to 6. Here is 0 and here is 6. What happened? They are not equal. That is why they are not associative. And similarly, in case of division, we are giving priority for 8 by 5 or by 3. See, just I present something, the rational only. If you are getting the integer values, it will be more clear to you. I left you that as an exercise. We do with the values within in getting the divided integers instead of rationals. Okay, think about another operation defined and star on R as a star equal to a plus 2b. A star equal to a star equal to a plus 2b is not associated. Think about the operation. Is it associative? I already told you it is not associative. Before. There is no chance to ask you, is it associative? So we can define. Instead of A, B, C, I took the values 8, 5, 3. So 8 plus 10. By the definition, I'm taking giving priority for brackets so that we can say. So we are able to 8 plus 5. 8 plus 5 is equal to 8, sorry, 8 star 5. 8 star 5 is equal to instead of 2 times of 5. Therefore, this is equal to 8 plus 10. And then we have instead of A, we have now 8 plus 10 is equal to 18. Now star 3. So 8 plus 10 star 3, 2 into 3, that is equal to 6. That is 8 plus 10 plus 6 equal to 20. So now this is okay. Uh, Similarly, we are taking 8 star 5 star 3. We are giving priority for 5 star 3. 5 star 3. We are giving priority for 5 star 3. So for the 5 star 3, for the 5 star 3, have by the definition 2 b's here. That is why we can say that. I just left that. 8 star, 8 star, 5 star 3. For 5 star 3, instead of B, we have 3 is there. 2 into 3 equal to 6. And we have 5 plus 6 is here. So now the B part is 5 plus 6. Now the B part is 5 plus 6. And 5 plus 6 is 11. So 8 star 11 is here. And that is why we can say that 8 star 11, 2 times of 11, that is equal to 22. 8 plus 22 equal to 30. So, both the cases, the first part is star 5, star 3 equal to 24, and similarly 8 star 5 star 3 equal to 30. So, it is clear that in both these cases, they are not equal. That is why there is not. So, just we are giving a note here. Property of binary operation is very important in the sense that with this property of binary operation, we can write A1 star, A2 star, etc. In absence of this property, the expression A1 star, A2 star, etc. is ambiguous unless the brackets are used. Unless the brackets are used. Whenever the subtraction or division operation, recall this earlier class were used are more than one operation. So for binary operation plus come to here binary operation for binary plus one r. The interesting feature is the number zero. We'll move to another part. Now we discuss the commutativity of binary operation and associativity of binary operation. We are just stepping to loop theory. That is why just now I'm discussing to another one is there. We have here is an element of real number set and a plus 0 for any real number, a plus 0 is equal to a. And similarly, 0 plus a equal to a. That means any number a remains unaltered. A remains unaltered by adding 0. But in case of multiplication, the number plays the same role. While multiplying any real number with 1, there is no change for that real number. While multiplying any 1 with any real number, there is no change for that real number. So that is why in case say that instead of addition, in case of addition, as well as in case of multiplication, while adding any number with 0, there is no change for that number. Multiplying any number with 1, there is no change for 1. So they are 0 and 1 peculiar numbers in our discussion. So that given any operation star, a binary operation of star, we defined star from A cross A to A, an element E. Instead of 0 and 1, for the convenience, a general term, we took it as E. We took it as E. If it exists, may exist or may not exist. There is a, in case of some the identity element will not exist. So if it exists, is called identity of operation star. If it satisfies the property, A star E is equal to E star A. Then we can say that the E is the element. So we will move to another example. We show that zero is the identity for addition. And we want to prove we already done it. Just I mentioned only here. And identity element, and one is the identity element for one. Okay. But there is no identity for the operation. We understand. There is two operation with earlier, minus for R and division for R star. But R star is it is very clear that we done just before it is A plus 0. A plus 0 equal to 0 plus A equal to A. A into 1 equal to 1 into A. That is why it is very clear and simple it is that both they are the identity. We don't want to say it is again that mean what I mean is that we already done it is. But think about there is no element while you are subtracting two numbers. There you could not find you cannot find any of the number e such that a minus e is equal to e minus a will not commute, and therefore there does not similarly, the same thing will happen in case of the division. So there is no element. We are unable to find an element from R star such that A by E is equal to E by E. There may be a some number of elements that exist, but in all cases, that's don't mind that. Just in case of one or finite number of cases or many number of cases happen, but if there exists at least one case which fails to be an identity, that is enough to say that which there does not exist such cases. Okay, this I'm going to. So we can see that minus and division. Do not we discussed it is that the commutative. Basically, we have taken a set and then we defined an operation and then we define when that operation will be a binary operation. So after that, we discussed it is that when that operation will be commutative and similarly when that operation will be associative. So there are some sets or some operation are there which is commutative. There are some which is not commutative. There are some operation which is associative. There are some operation which is not associative. There are some operation, in case of some operation, there should exist an identity element. In case of some operation, this is very important in case of us while we are studying group theory. These are all the very basic facts in group theory. Now, my dear friends, we conclude that my negative or subtraction or division do not have identity element.